When it comes to teaching something like particle physics, it's very abstract to people. You're talking about things that we can't see with the naked eye, and the cloud chamber changes that.
The cloud chamber experiment is a physical embodiment of what particles as they're traveling through space look like. You see ions and you see water droplets that are attracted to these ions.
As a particle goes through, it essentially ionizes the gas, ripping electrons off, and you can see the track of the particle through the gas.
You can look at them and puzzle over them and try and understand what's going on. What am I looking at? An invisible world is made visible.
We have particle detectors that are operating that can characterize matter that's smaller than an atom. So one of the places that they do this is the Large Hadron Collider, which is in Geneva, Switzerland. They collide fundamental particles together. They're trying to visualize and characterize everything that comes out of these collisions.
When the particle passes through the sensor, it'll keep going, but it'll deposit some of its energy in the sensor as it goes, and we'll read out that signal. So what we get about the particle is the position in the detector, and also its energy and its momentum. While the physics is really what drives the program, there are definitely opportunities for all sorts of people to get involved.
We have people from Turkey, India, China, Japan, everywhere in the world coming to this one place, and everybody's collaborating.
And it's really cool to come into work every day and really see these people that are really passionate about hopefully making the discoveries that will drive the future.
So I think it's a very human instinct to be curious and to ask questions.
The work we do addresses really basic questions of what the universe is made of and how it works. One of the major targets in this is dark matter.
But we can't see it. We don't know what it is, and we don't know really its nature very well.
And what we would like to do, and what we're hoping to do, is to produce it in the laboratory through these very high energy collisions and measure its properties.
Who knows, maybe 20 years from now, we found the missing link or that one information that we needed to space travel, or to understand dark matter, or to understand gravity better.
What you'll see inside the cloud chamber are these little tracks, these paths that the particles traveled through, and it leaves this condensation trail. It's a lot like the contrails from a plane. The plane might not be there anymore, but you know it was there because it left evidence behind. That's exactly the same as a cloud chamber. Bigger particle detectors that scientists use for research at places like the compact muon solenoid at CERN, those can detect a variety of different particles, whether or not they're charged or neutral. But in this case, we can only see evidence of charged particles. It messes a little bit with your thinking because you start to realize this is happening all the time, but it's the first chance we ever get to really see them. It's one of those experiments you can do in the classroom that really grasps the attention of people. It really hooks people. That's always a battle in classrooms, is trying to engage your students and trying to get them excited about something. And the cloud chamber does that.